Students, now I'm going to start the next topic, and that is the Jacobi method. And after that, we will also talk about the Gauss Seidel method. Students, basically, these methods are the iterative techniques, and they are used to find out the solution of the system of linear equations. And if I am not exaggerating, then I must say that these methods are one of the easiest part in your course. So they are very simple and very interesting as well, but somehow it gives you the solution. And the most important thing is that you must be good in finding out the solution using the calculator. So you must be good in using the calculator. So you can, if you are able to use the calculator, as I have already told you the technique, so then you can very easily find out the values here. So students, if we start with the Jacobi method, so this Jacobi method basically makes two assumptions. And what is the first assumption? Student, it says that the system given here, so this system, students, so this system has a unique solution. And the second assumption is that the coefficient matrix A has no zeros on its main diagonal. Students, these are the diagonal elements like A1, 1, A2, 2, so on, A, N. So these are the diagonal entries. So they should not be equal to 0. So students, if any one of these diagonal entries are 0, then you must interchange the rows or interchange the columns so that the matrix becomes in such a way that the diagonal entry is not equal to 0. So this is a very important point, student. So students, I have rewritten the system of equation just to make it easy for you so that you will not have to go back again and again. So that's why I have written the same system here. So first of all, what is your step, student? Like from the first equation, so this is your first, like you just consider the diagonal entries, students. From the first row, this is your diagonal entry. So from this diagonal entry, you have to calculate the value of x1. So just write the formula x1. So x1 is equal to, students, just put all these things on the other side of the equation, and then divide it by a11. So x1 is equal to 1 over a11 into b1 minus a12 x2 minus a13 x3, and so on, minus a n xn. And see here, a11 is divided here. And similarly, students, now this is the diagonal entry here, the second row, second column. So this element. So now from this entry, find out the value of x2. So x2 is equal to 1 over a22 b2 minus a21 x1, and similarly so on up to a2n xn. And students, from the last, so you can find out the value of xn. So xn is equal to 1 over a n n into bn minus an1 x1 minus an2 x2, and so on, minus an n minus 1 x n minus 1 here. Now students, first of all, you need to make the initial approximation. How do you start the system? So of course you have to start with some initial value. You can choose any initial value, whatever you like, students. So no problem at all. And in most of the cases, people use the initial value to be 0 0 0 0 0. So like x1 is equal to 0, x2 is equal to 0, x3 is equal to 0, and so on up to xn is equal to 0. So these are called the initial approximation, students. and now you have the initial approximation. So this initial approximation should be substituted in this system to find out the next value, like the next value of x1, x2 and x3, and just insert these initial approximation here. So just see here in the next slide so that you will see how we calculate this one. So students, what it says, so just if you substitute these values, so the next iteration will be obtained. And now the next iteration is obtained. So these are the second approximation, or the actually this is the first approximation because the previous one was the initial approximation. Don't uh, add count as the first approximation. No, that was the initial approximation, and now you first calculate the approximation, so that gives you the first approximation, and then the second approximation, third approximation, and finally you will see that your solution is converging. And students, I guess it would be much better if we see an example applying the Jacobi method here. So this is the example number 1. So what it says, use the Jacobi method to approximate the solution of the following system of linear equations. 5x1 minus 2x2 plus 3x3 is equal to minus 1, minus 3x1 plus 9x2 plus x3 is equal to 2, 2x1 minus x2 minus 7x3 is equal to 3. And now, what is the question? It says that continue the iterations until two successive approximations are identical when rounded to three significant digits. Means up to three significant digits. So the value should be same in the previous approximation and the new approximation. Then you stop. Okay, I will show you how to stop. So students, I have just rewritten the system here. Uh, so you can get help from this, so you can easily find out this system x1, x2 and x3. So students, now you start. So x1 is equal to minus 1 over 5 plus, actually from this first equation you can find out the value of x1, students. So x1 is equal to minus 1 by 5 plus 2 by 5 x2 minus 3 by 5 x3, and similarly x2 this one, x3 this one. Now students, since you don't know the any initial value, so you just choose any value, whatever you like here the normal procedure in the normal way. So you choose, and in most of the books the initial approximation is considered as 0 0 0. So 0, x1 is 0, x2 is 0, x3 is 0. So now the first approximation will be x1 is equal to, students, put it in the first in this equation, minus 1 over 5 plus 2 by 5 into 0 minus 3 by 5 into 0. So that is equal to minus zero point 0.2. And student, actually in the question it was saying that up to 3 decimal places. So you just write the question in the 3 decimal places. And if you are not asked to do this in the 3 decimal points, so I think it's better if you just put in the 3 decimal, just 4 decimal points if it is not given. So now student, x2 here. So x2 2 by 9 plus 3 or 9 0 minus 1 by 9 0, and that is approximately 0.222. So just use the calculator. If you just put the formula, if you write the formula in your calculator and just, and it will ask you the values for x and y or z, so you can simply give the values here and you get the answer in this way. So now okay, so x3, so x3 is equal to this formula, students, again put the values. So this one is equal to minus 0.429. This is approximately equal to, because this is not the exact value, so rounded off or chopped the values, so that's why we have put the approximate equal to. So student, this was the first approximation, and similarly you can find out the second approximation. What you do is you just put all these values, new values x1, x2, x3, in the again the same formula. So you get new values x2, x3, x1, x2, x3, the second approximation. Similarly, the third approximation, second, fourth, third, fourth, fifth, and in most of the book students, what it says, they write x1 here, they put 0 on the superscript 0 in the brackets. So x1 like bracket 1, 1, 1. But whatever you like. So I think, but in most of the books, it's written like this, like x1 here 0, it's 1, like this is the first, just to show you that this is the first approximation. So let's continue in this way and we will have the sequence of approximations. So students, when n is equal to 0, so this was the approximation. When n 1, here this approximation, 2, so this approximation, 3, this approximation, 4, this approximation, 5, this approximation, 6, this approximation, and 7, this approximation. Student, now you can see in the 7th approximation, you see, compare with the 6th value. So what it gives you, 0.186, 0.186, 0.331, 0.331, 0.423, 0.423. So you see that now you should stop because all the three points, up to 3 decimal places, the values are same. So student, this is your answer. So x1 is equal to this one, x2 is equal to this one, and x3 is equal to this one. So this is the solution of the system of linear equation by using the Jacobi method.